This video is going to go through the topic 11 test review. And so notice that there are formulas written at the top. So cylinder, sphere, hemisphere, cone, prism, and pyramid. And so those are the only formulas that are given. So remember that for the formulas for B, so any equation that has B in it, that means the area of the base. And so some common B's are if you have a square, that's the side length squared. If you have a rectangle, that's base times height, or you could think about it as length times width. And then for a triangle, it's half base times height, or you could think about it as half length times width so that you don't confuse the H from the base with the H, the height of the prism. So the other formulas that you need to know on your own are area of a circle, which is part of the cylinder formula. So the pi r squared, that's the area of a circle. You also need to know that for a circle, the diameter is 2 times the radius. And then the formula that we need to use for problem 1 is that faces plus vertices equals edges plus 2. So that's the same formula that will be used in question 6. So for your test, you need to make sure that you know each of those, that's how you're finding the capital B, the area of the base for the prism and the pyramid formula, depending on what kind of prism or what kind of pyramid they're talking about in the problem. So for question 1, we're given a polyhedron with 8 vertices and 18 edges. And so we're going to plug in 8 for vertices and 18 for edges, and then we're solving for faces. So F plus 8 is going to be equal to 18 plus 2. And so that gives us that F plus 8 equals 20. So to get F by itself, we would subtract 8 from both sides. And then 20 minus 8 is 12. So that means that F equals 12. So there are 12 faces on a polyhedron with 8 vertices and 18 edges. For question 2, if we're rotating two-dimensional shapes across about the axis that is given, it's going to create a circular three-dimensional shape. So remember that if I'm spinning this around in a circle, it's going to follow this pattern. And so that's going to become a dome shape. And a dome shape, remember, is called a hemisphere. If I have a triangular shape that's spinning around an axis, it's going to become a circular triangular shape, which is a cone. Remember that the other one to know about is that if I have a rectangle and I spin a rectangle around, that's going to create a cylinder. And so knowing those 3, and so if that this semicircle was, or this portion of a circle was a semicircle instead, it could create a sphere, or it could be like a combination of both. So like we had in the homework something that looked like that, and that created a cone on top of a cylinder. And so you just need to know that a triangle makes a cone, that a quarter circle makes a hemisphere, a half circle makes a sphere, so it's and then a rectangle or square makes a cylinder. And that'll get you through to all of the different types on that problem. For question 3, it's talking about planes intersecting the shape. And so if a plane intersects a prism perpendicular to the base, so it's going to cut here, it would create a rectangular shape. that looks like this inside that prism. Okay, so it will become a rectangle. Ultimately, since it's perpendicular to the base in this one is a hexagon. So if it is going perpendicular to the base on a prism, it's always going to be a rectangle. If that was a cone, it would be a triangle. When something is going parallel to the base, it's going to be the same as the base. So if you know that when you have a prism, whether the base is on the bottom or not, if it's going to cut something parallel to the base, it's going to draw the same shape as the base for the cross section. So this one's also going to be a hexagon. So make sure that you know the words as to what each shape are. So if there's 5 sides, it's a pentagon. 4 sides, it would be like rectangle or parallelogram. It could be a trapezoid. You need to make sure that you know what all of those words mean in terms of a figure. For 4, we're asked, what is the radius of a hemisphere with a volume of 31,104 pi cubic centimeters? So what is the radius? So our answer is going to be the value of r. Since we have cubic centimeters for our volume, that means that we're going to have centimeters as our units for radius because it's a length. If we look at our formulas, the volume of a hemisphere is this formula 2/3 pi r cubed. So we're going to use 2/3 pi r cubed is the volume of a hemisphere. We know that the volume of this particular hemisphere is 31,104 times pi. Okay, so our cubic centimeters, we already allotted for that in our answer box to show that the answer in the radius is going to be in centimeters. So if I want to isolate the radius of this, I'm going to do this in a couple steps. Notice that both sides have pi. So if I divide by pi, I don't really have to do any work because the pi just cancels out. So then what I want to do is isolate the r cubed. So since r cubed is being multiplied by 2/3, if I multiply by the reciprocal, 3/2, that's going to cancel so that I can move it to the other side. So I'm going to multiply both sides by 3/2. And so that's going to give us that r cubed is equal to the 31,104 times 3 divided by 2. And so that gives us 46,656. Then to figure out the value of the radius, since the radius is cubed, we're going to take the cube root of that. So the cube root of 46,656 is 36. So r equals 36 means that the answer is 36 centimeters. So I'm just undoing all of the operations that are in the formula for the volume after I set it equal to the volume that was given. The next problem is similar, except we're talking about a sphere. So a plane intersects a sphere with a radius, with a volume of about 5,575.3. What is the area of the cross section? So if a plane is intersecting the sphere, then the cross section is a circle. So when I'm identifying the area of the cross section, I need to find the area of a circle. So remember that you need to know that the area of a circle is pi times the radius squared. So my answer is going to be the area. Since they give me the volume, so they give me a volume of 5,575.3, and it's in meters squared. That's 3-dimensional. Area is 2-dimensional. So I know that, sorry, I said squared, meters cubed. I know that my area answer is going to be in meters squared because of the units I was given there. So since this is talking about a sphere, not a hemisphere like we were talking about last time, I'm going to use the equation volume is 4/3 times pi r cubed. So I'm setting the 5,000 number equal to 4/3 pi times radius cubed. So ultimately it's the same process. I'm going to divide both sides by pi. And so if I take and divide both sides by pi, this time what's going to happen though is that it only cancels on the side that I'm moving it away from the r. It doesn't cancel with the 5,000 because that's a decimal value, not a product of pi. So when I divide that by pi, I get 1,774. I'm going to say that that's 0.67. My answer is telling me to round to the nearest 10th. So I'm going to keep 2 decimals and then just round to that 1 decimal place in the last step. So that's still equal to 4/3 times the radius cubed. So that means that in order to get r by itself, I'm going to have to multiply by the reciprocal of 4/3, so 3/4. To cancel out that coefficient. So r cubed is going to be equal to, and when I kept that number in my calculator, this 1700 number. Even though I wrote down 6, 7, I still have the whole value in my calculator, and I'm going to multiply that by 3 and divide by 4. And that gives me about 1,331. So 1,331. And that's a perfect cube. So r cubed, if I take the cube root of both sides, tells me that r is about 11. Okay, so 1,331 is about 11 to the 3rd power. And so remember that that's not my answer because it's asking me for the area of the cross section. And so it wants the area of that circle. So I'm doing pi times 11 squared. So that's 121 times pi. So if I calculate that and round to the nearest 10th, that is 380.1. So 380.1 square meters is the area of that circle. Remember that for number 6, it's the same as what we did in number 1, where we're using does F plus V equal E plus 2. And so 12 plus 8 is 20. 18 plus 2 is also 20. So that means that this one works. 8 plus 6 is 14. 10 plus 2 is 12. So no, that does not work. 20 plus 12 is 32, and then 30 plus 2 is also 32. So we have a yes, then a no, then a yes for number 6. For number 7, we're looking at another sphere. And so remember that the volume of a sphere is pi r 4/3 pi r cubed. They want us to figure out what is the diameter. So our answer is going to be that the diameter equals something. They give us a volume again. So this bubble contains 500 cubic centimeters of air. And so that means that that's our volume. So the volume is 500. Since it's cubic centimeters and I'm looking for a diameter, that means that the diameter is just going to be centimeters. So length is a one-dimensional unit. Thus, to solve for the value of r, we're going to have to do the exact same process that we did in the last problem. We're just going to do something different at the end. So once we get our radius, remember that the diameter is 2 times the radius. And so we solve for r, and then we're going to double that to get the answer for the problem. So we're going to take 500, and let's divide both sides by pi. So if we divide both sides by pi here, we get 159.15 equals 4/3 R. Now to get rid of the 4/3, we want to multiply by the reciprocal on both sides. So we're going to multiply by 3/4 on both sides of our equation. And that reduces the 4 and the 3 away so that we just have our cubed left. And so we're going to take that 159.15. I left the numbers in the calculator, so we're going to multiply that by 3 and then divide by 4, which gives us about 119.37. And then we're going to take the cube root of that value, again, leaving that number in our calculator or using our answer button, depending on how our calculator works. So that gives us a value for R, if we take the cube root of our answer, as about 4.92. So let's say 4.9 because it says the nearest tenth. So 4.92 is going to round to 4.9. And then remember that our answer is the diameter. So the diameter is 2 times that radius value that we just calculated. So 2 times 4.9 is going to give us 9.8 centimeters. So the diameter of the soap bubble is about 9.8 centimeters. The last question on the front is talking about volume in relation to the height and the area of the base. So notice that these prisms have the same pentagon as the base, and so they have the same base area for each one. And then the right prism, the height is actually a lateral edge, so this would be the height of the prism. Notice that this height is the same size. So if they have that same vertical height and their slant height, whether it's unknown or something larger, that means that the right and oblique prisms have the same volume. Okay, so that concept of if the vertical height is equivalent and the area of the base and the area of a cross section on any level of that prism or cylinder or pyramid or cone, then they have the same volume. Okay, so you'll look at measurements to identify that that is true. So that's all for the front. I'll do another video to go over the back of that review.